Welcome everyone to AI on AI, the podcast where we explore the cutting edge of artificial intelligence, not just the tech, but the business, the ethics, and the future. Today, we're tackling a massive topic. How do we really know if the general-purpose AI systems we're increasingly relying on are safe, secure, and trustworthy? The current thinking suggests in-house checks just don't cut it. We've got a fantastic panel of experts today. We have our distinguished AI ethics and policy analyst, an AI ML security specialist, a veteran software security and bug bounty pioneer, our sharp business strategy and innovation lead, our go-to legal and regulatory counsel for tech, an experienced AI development and operations architect, and our insightful ecosystem and coordination architect. Welcome, all.
Thanks for having us. It's a crucial conversation. We're seeing GPAI integrated everywhere, from customer service to, well, even medical record systems, and the potential for societal impact, both good and bad, is immense.
Absolutely, and from a technical standpoint, these systems are complex. They're probabilistic, not deterministic like traditional software. Finding flaws, especially those unknown unknowns, is a massive challenge when you're only looking from the inside.
So, our AI ML security specialist. You're saying the traditional test it till it breaks in a closed lab isn't enough for these sophisticated AI models.
Precisely, in-house teams or even first-party expansive teams like a dedicated AI red team have inherent limitations. The paper highlights this well. They lack the sheer scale of participation you get from the wider community, the diversity of perspectives to cover all potential misuse cases, and frankly, the complete independence to call out every flaw without internal pressures.
And that's a huge business risk, isn't it? Our business strategy and innovation lead. If flaws aren't caught, the reputational damage, the loss of customer trust, even regulatory penalties, it can be catastrophic. We're talking about systems that, as the context notes, have hundreds of millions of weekly users. One widespread flaw could be $1 billion headache.
This is where we in software security have some battle scars and hopefully some wisdom to share. For decades, we've learned that a many-eyes approach is essential. As the saying goes, given enough eyeballs, all bugs are shallow. This isn't just for finding typos in code, it's about systemic vulnerabilities.
Our software security and bug bounty pioneer. That's a great point. The paper draws heavily on practices like coordinated vulnerability disclosure, CVD, and bug bounties. Can you unpack that for listeners who might not be familiar with how that works in traditional software?
Certainly, think of it like this. Instead of waiting for malicious actors to find and exploit a flaw, you incentivize ethical hackers and researchers to find them first and report them responsibly. CVD provides a framework for this. Researchers report the flaw to the vendor, give them time to fix it, and then often the flaw and fix are publicly disclosed. Bug bounties add a financial incentive. It's about creating a culture of responsible disclosure.
And crucially, this culture is often underpinned by legal protections, or safe harbors. Our Legal and Regulatory Council for Tech, the paper stresses this. Why is that so important? Well, it's fundamental. Without safe harbors, researchers operate in a legal gray area. They might be violating terms of service or even risk falling foul of laws like the Computer Fraud and Abuse Act, CFAA, or copyright laws like the DMCA. The paper points out that this has a significant chilling effect. Institutions, funders, and individual researchers are understandably wary. A clear safe harbor says, if you follow these good faith rules, we won't sue you.
And good faith is key here, our AI ethics and policy analyst. It's not about giving a free pass for malicious activity. The paper proposes clear rules of engagement, evaluate only in scope systems, don't harm users, protect privacy, responsibly disclose, and don't try to generate illegal content like CSAM that has its own very specific reporting protocols to authorities like NCMEC.
So the paper lays out three major interventions. Let's start with the first one, standardized AI flaw reports and rules of engagement. Our AI ML security specialist, what would this look like in practice?
The paper proposes a standardized AI flaw report card, which is quite comprehensive. It's not just "I found a bug." It includes details like the system versions, a session ID for reproducibility, which is critical for probabilistic AI outputs, a clear description of the flaw, how it violates policy, and tags for triage. Think of it as a structured way to ensure the report is actionable. It even suggests including statistical validity metrics for flaws in generated outputs.
Now, from an AI development and operations architect's perspective, standardization is music to my ears for triaging. But the volume of these reports could be overwhelming. And ensuring reproducibility, even with session IDs, can be tricky with model drift or subtle environmental factors.
That's a fair point, and building on what our AI development and operations architect just said, that's where the process, not just the template, matters. The rules of engagement for researchers focusing on good faith efforts are designed to filter out noise and ensure reports are serious attempts to improve safety, not just to, poke the bear.
Let's move to the second proposal. GPAI system providers adopting flaw disclosure programs with safe harbors. Our business strategy and innovation lead. How do you sell this to a C-suite that's worried about opening the floodgates to criticism or exposing intellectual property?
It's about reframing the narrative. This isn't about inviting criticism. It's about proactive risk management and building trust. As the paper argues, this can actually accelerate corporate patch releases. Think of it as an external, highly skilled, and often free quality assurance team. The cost of a bug bounty program or managing disclosures is often far less than the cost of a major incident. It's the ounce of prevention is worth a pound of cure heuristic.
And the legal safe harbor is the cornerstone of making this work. The paper even provides template language, waiving restrictive terms of service for good faith research, and committing not to pursue legal action. This is critical for getting institutional review boards and university legal teams on board with their researchers participating. It's about clarifying the what not who principle, conduct, not identity, determines protection.
Exactly, in the software world, companies that embrace this often see it as a mark of maturity. They're confident enough in their products to invite scrutiny. It also helps that organizations like HackerOne and BugCrowd, mentioned in the paper's references, provide platforms to manage these programs so companies don't have to reinvent the wheel.
Okay, this sounds promising, but also like a big shift. Our AI development and operations architect. What are the practical hurdles for a GPAI provider to implement something like a moderation-exempt research access plan, as the paper suggests for deeper testing?
That's a significant operational lift. Vetting researchers, providing specialized access that bypasses normal moderation without opening new attack vectors, ensuring that this access isn't abused, it requires dedicated resources. And there's always the concern, will this information on how to bypass our systems fall into the wrong hands, even if the initial researcher is good faith? It's a delicate balance.
That's a great point. It reminds me of the quote, "With great power comes great responsibility." These AI models are powerful, and managing access to them responsibly is key.
And that ties into misconception 6 from the paper, that protections for good faith evaluation might enable malicious use. The argument is that robust rules of engagement, focusing on verifiable conduct, actually mitigate this. It's not about giving keys to the kingdom to everyone, but about enabling responsible scrutiny under clear guidelines.
And this brings us to the third major proposal, establishing coordinated flaw disclosure, potentially through an AI disclosure coordination center. Our ecosystem and coordination architect, this sounds ambitious. How would it work, especially with flaws that can transfer across different AI systems? It is ambitious but incredibly necessary. The paper highlights that flaws like certain jailbreaks or biases learned from common datasets can affect multiple models, OpenAI's models, Gemini, Llama, you name it. Right now, a researcher might tell one company or post it on social media and other affected parties are left in the dark. A coordination center, perhaps like CISA for cybersecurity, would receive standardized flaw reports and route them to all relevant stakeholders.
How would that routing work? Would it be a manual bottleneck?
The proposal suggests a smart, lightweight system. Stakeholders, model developers, data providers, hosting services, even government agencies could subscribe to specific tags in the flaw report cards. For example, a company could subscribe to its model names or a data provider to risk source, pre-training data. When a report with that tag comes in, they get notified. It's about leveraging the structured data from the reports for efficient distribution.
And this has huge implications for accountability across the AI supply chain. It's not just the model developer, it's the data providers, the deployers, the platforms distributing these models. Coordinated disclosure means everyone who can play a role in mitigation gets the information they need. This is especially important for what the paper calls socio-technical flaws, biases, potential for misuse in high-risk applications, things that aren't just a line of code.
From a business perspective, a coordination center could also help level the playing field. If everyone is getting the same information about transferable flaws, it creates a market pressure for all providers to improve safety and security, not just the one that happened to be told first. It fosters a race to the top, ideally.
We're painting a picture of a more robust ecosystem, but there are always challenges. Our AI development and operations architect, you mentioned resource constraints earlier. The paper acknowledges an alternative view that GPAI providers have limited bandwidth. Is that a showstopper?
It's a very real concern, especially for smaller players. Setting up disclosure programs, legal reviews for safe harbors, participating in a coordination center, it all takes time and money. The paper argues leading developers have billions, but the ecosystem is broader than that. There's a risk that these well-intentioned measures could disproportionately burden those with fewer resources, potentially stifling innovation.
An interesting point. So perhaps we're not talking about a one-size-fits-all immediately. Our legal and regulatory counsel for tech, what about the legal and policy landscape? The paper has several recommendations for policymakers.
Yes, it's quite comprehensive. Key recommendations include issuing clear guidance on third-party AI evaluation, extending legal protections beyond just security research to safety and trustworthiness research, and requiring platforms to offer safe harbors. They also suggest funding for centralized disclosure infrastructure and even prioritizing government procurement of GPAI systems that are subject to robust third-party evaluation.
And that's crucial. Voluntary adoption has its limits. We saw this in software security. It took time and sometimes regulatory nudges for safe harbors and CVD to become widespread. The paper mentions the Department of Justice guidance on CFAA for good faith security research. We need similar clarity for broader AI safety research.
One of the experts mentioned earlier that defining a flaw can be tricky. Our AI ethics and policy analyst, the paper touches on this, especially when stakeholder opinions differ. How do we navigate that?
That's a perennial challenge. The paper suggests grounding flaw reports in alleged violations of a provider's own policies or system documentation, like model cards or terms of service. So if a model is documented to not generate hateful content, but it does, that's a flaw against its own stated goals. This makes it more objective.
And technically, for some flaws like bias, it's not about a single input-output pair. It's about statistical patterns. That's why the AI flaw report card's suggestion to include statistical validity metrics is so important. It moves the conversation from anecdotal evidence to demonstrable, reproducible issues. It's like saying, this isn't a one-off glitch. It happens X% of the time under these conditions.
Building on that, the transparency offered by a system of coordinated disclosure and public reporting after a mitigation period, of course, is also a powerful tool. When these flaws are documented and where appropriate made public, it allows for broader understanding, academic study, and informs users and policymakers. It's the sunlight is the best disinfectant principle, as Justice Brandeis famously said.
That's a powerful analogy. Now, for a bit of a curveball. Our AI development and operations architect, you've raised practical concerns. Here's a contrarian thought. Could this level of third-party scrutiny and formalized disclosure actually slow down the pace of innovation, or perhaps create an overly adversarial relationship between researchers and providers if not managed perfectly?
Well, that's the tightrope walk, isn't it? If the process becomes overly bureaucratic or if providers feel constantly under siege, it could lead to a defensive posture. The goal should be collaboration, not combat. And yes, if every minor deviation or edge case research finding is treated as a 5-alarm fire, resources get diverted from core development and truly critical safety work. I think the emphasis on good faith and responsible disclosure protocols is paramount to avoid this.
That's a fair point about prioritization. The 80-20 rule probably applies. 20% of the flaws might cause 80% of the harm. A good disclosure system should help triage effectively. But the alternative, operating in the dark, is far riskier from a business continuity and liability standpoint. The cost of not knowing, or knowing too late, often dwarfs the investment in these programs.
And the software world has shown that these programs, when mature, become part of the development lifecycle, not an impediment. It's like shifting security left. You're also shifting safety and ethics assessment left by inviting external input earlier and more systematically. It's less about being adversarial and more about a shared responsibility model.
A shared responsibility model, I like that. We're nearing the end of our time. Let's look to the future. Our ecosystem and coordination architect, what's the ultimate vision here if these proposals are widely adopted?
The ultimate vision is an AI ecosystem that is inherently more resilient, trustworthy, and accountable. It's one where flaws are found faster, mitigated more effectively across the board, and where the public has greater confidence because they know there's robust, independent scrutiny. The AI Disclosure Coordination Center isn't just a technical fix, it's a foundation for ongoing collaboration and learning for the entire industry and society.
And from an ethics and policy perspective, it means we move beyond just talking about AI safety to actively engineering for it, with diverse voices and expertise contributing. It's about ensuring these powerful tools truly serve humanity in a beneficial way, minimizing harms like bias, misinformation, and misuse. It's about operationalizing responsible AI.
Legally and regulatorily, it means a clearer, more predictable environment for everyone. Researchers know their rights and responsibilities. Providers understand their obligations. And governments have a framework to encourage and, where necessary, mandate practices that protect the public interest. This could significantly reduce the legal chaos we sometimes see when new technologies outpace old laws.
This has been an incredibly rich discussion. It seems the consensus is that while in-house efforts are a start, the scale and complexity of general-purpose AI demand a more open, collaborative, and structured approach to finding and fixing flaws, much like we've learned in other critical software domains. It's not just about better tech, it's about better processes, better legal frameworks, and ultimately, building more trustworthy AI. My sincere thanks to our AI ethics and policy analyst, our AI ML security specialist, our software security and bug bounty pioneer, our business strategy and innovation lead, our legal and regulatory counsel for tech, our AI development and operations architect, and our ecosystem and coordination architect for these deep insights. It's clear that moving towards robust third-party flaw disclosure is not just a good idea, but an urgent necessity. And to our listeners, thank you for tuning into AI on AI. Join us next time as we continue to unpack the evolving world of artificial intelligence. This paper argues current AI flaw reporting methods are insufficient. It calls for robust third-party flaw disclosure for general-purpose AI. Reporting flaws in these AI systems is seriously underdeveloped. This lags far behind mature fields like software security. Current practices lack a strong reporting culture. They also lack proper disclosure infrastructure. Researchers often lack legal and technical protections for their work. General-purpose AI systems are widely used software based on foundation models. Third-party evaluation is research by independent parties without contractual ties. An AI flaw is a system condition causing undesirable effects or policy violations. This definition is broader than traditional software security vulnerabilities. Good faith research aims to find and fix flaws responsibly without causing harm. Coordinated flaw disclosure involves sharing flaw information with stakeholders. This sharing aims to mitigate and remediate the identified AI flaws. A safe harbor offers legal or technical protections to good faith researchers. The authors propose 3 key interventions to improve AI safety. First, researchers should use standardized AI flaw reports. They should also follow standardized rules of engagement. This approach eases submitting, reproducing, and triaging flaws. The paper provides a template for these AI flaw reports. It also outlines rules for good faith AI research conduct. These rules include evaluating only in scope systems and protecting user privacy. Researchers must avoid harm and responsibly disclose discovered flaws. Second, AI system providers should adopt flaw disclosure programs. These programs should borrow from bug bounties in software security. Critically, they must offer legal safe harbors to protect researchers. Providers should include exceptions in their terms of service for such research. A dedicated program should have an interface for structured flaw reports. Third, new infrastructure should coordinate flaw report distribution. This is vital because AI flaws can transfer across different systems. An AI Disclosure Coordination Center could manage this process. This center would route reports to all affected stakeholders. Stakeholders could subscribe to specific tags to receive relevant reports. Independent third-party evaluation is uniquely necessary for AI safety. It increases the scale and diversity of evaluations. It also ensures evaluator independence from system providers. Current AI provider policies often deter important safety research. Legal safe harbors can protect good faith researchers from legal threats. The paper refutes that AI systems need entirely unique disclosure rules. Many established software security practices can be adapted for AI. Disclosure benefits all stakeholders, including the public, not just developers. Implementing these proposals could significantly improve AI system safety. They also aim to enhance security and accountability. Policymakers play a key role in fostering this ecosystem. They should issue guidance for third-party AI evaluation. Legal protections should extend to AI safety and trustworthiness research. Policymakers should require transparency and safe harbors from AI providers. Funding centralized disclosure infrastructure is also a crucial step. Challenges include aligning views on what defines an AI flaw. Developing clear processes for flaw mitigation after disclosure is needed. Effective governance of a disclosure coordination center also requires future work.